Here we have an 11.2. It says in the diagram, O is the center of the circle, RMPS. So you guys remember that when a circle is given a particular name, like in this case, RMPS, those are just the points that lie on the circumference of the circle. So a circle is named according to the points that lies on its circumference. It says T is the midpoint of RM. Now, if you look at line RM, yes, it does make sense why T is the midpoint, because we see that RT and TM are equal to each other. Basically, that line RM has been bisected. Angle R is 50 degrees, so that is given to you here, angle R being 50 degrees. Now, firstly, it says calculate with reasons the value of the following. So the first angle we are looking for is O2. Now what I want you guys to notice is that points P and M subtend to O2, and O2 is at the center of the circle. P and M also subtend to angle R, which is on the circumference. Now you guys notice that O2 is subtended by PM and angle R is subtended by PM, but O2 is at the center. What we know is that the angle at the center is 2 times the angle at the circumference. So angle O2 is 100 degrees. And our reason for that is angle at center. Next, we are looking for angle S. Now, what I need you guys to notice here is that S is subtended by points P and M. And what do we mean by the word subtend? We mean that these points basically create angle S on the circumference. What we'll also notice is that angle R is also subtended by points P and M. So notice angle S and angle R, both on the circumference, they're both subtended by points P and M, which means that angle S and angle R are equal to each other. And the reason for them being equal, that is angles in the same segment. Next, we need angle P1. Now, to get angle P1, I need us to focus on triangle POM. Now, what you're going to notice about triangle POM is that it is an isosceles triangle. Firstly, why is it isosceles? Remember, an isosceles triangle has 2 sides equal. Here we have OP and OP that are OP and OM that are equal to each other because they are radii. Now, where we have 2 sides equal, we also have 2 angles equal, meaning that in this triangle POM, angle P1 and angle M in this triangle are equal to each other. Now, since we know the third angle, which does not form part of one of the 2 equal angles, we can easily calculate this. All we have to say is angle P1 is equal to 180 minus 100 divided by 2. Now, why do we divide by 2? It's because once we subtract the 100, whatever we're left with, we divide it by 2 in order to get those 2 equal angles. So that makes sense, right? Now remember that in grade 11, we no longer say isosceles triangles. Instead, we use the reason as equal angles, opposite, equal sides. And you're welcome to write the equal as an actual equal to, so as the symbol. Now, solving for P1, we should get angle P1 as 40 degrees. So here is P1 on the diagram, 40 degrees, and I'm just going to indicate that portion of M as well as 40. Next, we need angle T1. Now, we've already mentioned this. Actually, at the start, we mentioned that the chord RM was bisected, and they told you that T is the midpoint. Now, you guys, this should remind you of the theorem, the first theorem that says when a line is drawn from the center of the circle and it bisects the chord, it has to be perpendicular to the chord. So this is perpendicular bisector. Angle T1 is 90 degrees. And obviously, next to that, angle T2 would also be 90 degrees because we know angles on a straight line are supplementary. But at the moment, we do not need T2, we just need T1. So we're going to say angle T1 is 90 degrees, and the reason is perpendicular bisector. Now 11.2.2 says, show by calculations that TOPM is not a cyclic quadrilateral. Let's first find that shape. We have TOPM. So here is the quadrilateral TOPM. And what we are required to show is that it is not a cyclic quad. Now, obviously, you have to do this through calculation. So let's go with the first rule. We know that in order for this to be a cyclic quad, opposite angles are supplementary. If we take the known opposite angles here, where we've got T1 and we've got P1, when you add this, you will get 90 plus 40 degrees, which is 130. Clearly, those angles are not supplementary. Only if it is a cyclic quadrilateral, then the opposite angles will be supplementary. So all we have to do here is show that we are adding those opposite angles, and they were T1 plus P1. So angle T1 plus angle P1, that is 90 degrees, plus 40 degrees, which is 130 degrees. That is not equal to 180. That's not equal to 180. Therefore, TOPM is not a cyclic quad. And if you want to go one step further and say why it's not a cyclic quad, you can say that the opposite angles are not supplementary. So yeah, that is good enough. There was another way that this could be done. You could work with, just to show you, you could work with T2 as being the exterior angle, and we know if it is a cyclic quad, exterior angle is equal to interior opposite. Now, if we were going to have an interior opposite, it would be P1, and you can show that, hey, T2 is 90, but P1 isn't 90. So the exterior angle is not equal to the interior opposite angle. That was another way of showing that. Okay, so we are done.